Hello and welcome to Chips Weekly by Diana, your weekly dive into the moves, milestones and breakthroughs shaping the semiconductor industry. I am Diana. This week was rich with developments. We'll begin with ARM's launch of its Lumex architecture, a family of the chip designs meant to bring AI directly onto mobile and wearable devices. Then we'll turn to Samsung expansion of EUV capacity in South Korea. It's a bold investment aimed at catching up to TSMC at the most advanced nodes. And next, we'll explore an exciting research breakthrough, an optical AI chip that uses light instead of electricity to perform AI computations at a fraction of the power. In our industry spotlight, we'll examine TSMC's accelerating momentum in the market with the stock gains reflecting surging AI demand. And finally, we close with our chip of the week. Let's start with ARM's big AI bet on the edge. And star number one, ARM's launches Lumex for mobile AI. This week, ARM unveiled Lumex, its next-generation chip architecture for smartphones, wearables, and other edge devices. Unlike incremental past upgrades, Lumex is designed from the ground up for on-device AI inference, from real-time translation to image generation without relying on the cloud. The Lumex family spans ultra-low power cores for earbuds and health trackers up to high-performance versions of the flagship smartphones. They're optimized for 3nm nodes at the foundries like TSMC, with embedded AI accelerators, smart memory hierarchies, and a keen balance between the speed and efficiency. ARM's bet is clear. The future of AI isn't just in massive data centers. It's in your pocket, on your wrist, and even in your glasses. If successful, that could reduce latency, improve privacy, and redefine how developers design mobile AI experiences. Story number two. Samsung expands EUV capacity in South Korea. Samsung met headlines with its decision to expand extreme ultraviolet lithography capacity at a site in South Korea. This investment is designed to strengthen Samsung's competitiveness against TSMC in the cutting-edge nodes like 3nm and beyond. While Samsung struggled with yield compared to TSMC, bolstering EUV production at home underscores both its ambition and the strategic importance of anchoring semiconductor capacity within South Korea. The move comes at a time of surging AI demand, where foundry availability, not design, is often the bottleneck. By adding more EUV lines, Samsung signals to its global clients, from Qualcomm to NVIDIA, that it intends to be a serious alternative for a next-generation supply chain. The challenge, however, will be yield and consistency. More tools alone won't close the gap with TSMC, but it's a clear statement that Samsung is still in the fight. Story number three, the new light-based AI chip for optical convolutions. Researchers at the University of Florida this week introduced a prototype optical convolution chip designed to perform AI operations using photons instead of electrons. In lab tests, the chip reached nearly 98% accuracy on a standard classification tasks, but at 100 times lower power consumption than the conventional processors. By routing computations through the micro-lens arrays, the light beams, the chip reduces heat and energy dramatically. If scaled, this could transform both mobile AI and data center workloads. Imagine smart glasses that run computer vision all day without draining the energy. All server farms slashing power bill by offloading inference to optical accelerators. It's early days, but this breakthrough hints at the future where light itself becomes a cornerstone of AI hardware. Industry spotlight, TSMC's market momentum. While ARM innovates and Samsung expands, the heartbeat of the global chip industry remains with TSMC. This week, TSMC stock was upgraded to a strong buy as analysts pointed to the robust 3nm record AI chip orders and a stronger than expected earnings. Investors increasingly see TSMC not just as a supplier, but as a critical enabler of the AI era. That momentum feeds into the policy, investment, and the customer strategies worldwide. It means more contracts, more fabs, and a deeper reliance on TSMC ability to deliver, while also raising the stakes should disruption ever hit. Finally, the chip of the week. This week, for our chip of the week, we head to India, where a country has unveiled the Vikram-32, its first fully local 32-bit microprocessor. Developed under India's Semiconductor self-reliance programs, Vikram-32 is designed for IoT, industrial control, and defense systems. Built on the open RISC-V architecture, it provides India with a sovereign alternative to imported microcontrollers and embedded processors. What makes Vikram-32 so significant isn't just a technical achievement, it's a symbolism. For decades, India's electronics sector relied on imported silicon. Now, nations has a microprocessor it can call its own, with IP fully controlled domestically. And this is it for episode 18 of Chips Weekly by Diana. If you enjoyed this episode, don't forget to subscribe, share, and connect with me on LinkedIn or X. Diana on Chips. Until next time, stay inventive, stay resilient, and as always, stay chip aware.